My name's Tom, and I'm joined with Harry as well,
Yep, thanks.
one of my colleagues. We're in the Cloud and Core Foundation team, so generally sort of cloud networking, core networking, and we're just going to go through with you today some of the use cases that we've got using NSO, and also our journey to orchestration, automation, enlightenment. So yeah, bringing that to fruition. So a couple of quick introductions.
Yeah, sure. Hey, my name's Harry Watson. I've worked at Cisco since 1997, and probably like a lot of you, my primary role when I moved in was as a network engineer. And as I carried on working there, I started working with Perl scripts to try and automate some of the really boring stuff that we do. And as that's carried on, we're at where we are today with NSO.
Thanks, Harry. Yep, again, my name's Tom Fincher, network engineer. I've been at the company for 3 years, joined as a graduate, and have probably in the last year and a half have started really developing in Python. I was PHP before, and I know some people really disagree with using PHP, but yeah, no, Cisco's generally very Python-based, especially in Cisco IT. So a quick agenda. So we're going to go through the automation journey, how we as an organization sort of went through, how we adjusted, how we got to a stage where we're using NSO quite continuously throughout what we do. We're going to talk about the NSO use cases that we have, so some of the things that we actually have in production. A quick demo, the network tomorrow, so what we see as how we're going to be using this whole orchestration automation lifecycle, and sometimes some questions as well. So what does our network look like? So we basically connect all the continents, all the countries that you see here. We're responsible for basically making Cisco tick over in terms of getting data across the whole globe. So from the map, you can see where we connect point to point. And you can also see which devices, where we're using everything, amount of wireless LAN controllers. I mean, depending on what company you're with, it may be bigger, might be smaller, but generally for us, it's quite a huge infrastructure to look after. So yeah, you can see sort of almost 9,000 LAN switches, a lot of all different types of routers, so up to 6,500. And also, we have the WAE infrastructure as well, so optimizing traffic, say, from Microsoft Update to Cisco TV as well, our internal broadcasting service. We also have Cisco Virtual Office, which is sort of, say, if you want to work from home, we're all about sort of the work-life balance, remote working. That's a big thing within the culture of Cisco. So what we do is we provide you with a small solution so that you can use IP telephony, connect as if you were at work, connect video endpoints, et cetera, and it's pretty much just going into your office. So actually, our network expands much further than the actual formal limits of our network. So just moving on. So the network yesterday. This might apply to some of you, depending on where you are in your NSO journey. So the orchestrator is generally the engineer. They'd go out, they'd look at devices, they'd go, that needs changing, that needs changing, that needs changing. And it would generally be a manual process to bring everything into compliance and to audit all these devices. So yeah, managed by individuals, typically network engineers, project managers, analysts, you name it, we've got it. The network was the source of truth. So in terms of circuit IDs, managing your interfaces, managing all your config, it was generally thought that your network device was the be-all and end-all, and that is where you get all your information from. That's slowly changing. I mean, some of you may agree that might be sort of where you want to leave your data. I mean, we certainly want to move it out and make it more centralized and more standardized. Applications were limited in capability. So what we mean by that is applications were generally adapted to the network. So you put the network in first, and then applications will work around that. We're trying to make it more intent-based, as you've probably already seen some of the Cisco material recently. We're changing it so that the network and the applications work hand in hand, bringing sort of a more streamlined solution. So if an application owner would request certain capabilities from the network, we'd then work with the applications to make sure that they have what they need in order to bring that application to fruition. One thing that has been repeatedly mentioned throughout the last couple of days is inconsistent implementation. So whether it's human error, whether it's fat fingering a command on a device, this is one big problem. NSO gets rid of that, and we've seen some of the benefits already. So it's getting to a point where we no longer have to worry about those issues going forward. And generally a long time to deliver new services. So to follow the basic waterfall model, we use that. I'd say we've changed that slightly recently, becoming more agile. But what it used to be was being a waterfall, so that you request the service, it gets designed, it gets sort of reviewed, it gets implemented, and then obviously you go back round to obviously improve or change the service. No, definitely more agile, definitely more NSO. So the network automation journey, I'm just going to do all that. So where we started off, ad hoc scripting. So one-time scripting for one use, for one purpose, one group of devices. That's where we started off. So say I wanted to do a password audit or I wanted to do an ACL audit. We would go off, create a script, and it would go and do its job. Done. We then sort of went on and said, well, actually, some of these scripts become more relevant, using them again and again. So we get to the point where we make it more generic, and we say, actually, we want these group of devices. We want to run these commands whenever we want to review, config, do an audit, etc. And then we thought, well, we could go one step further. We could orchestrate this. And obviously with NSO, it becomes more and more, it becomes easier to do this. So making it model-driven, we can define the standards, we could make it fit to that device, and obviously all the services that that device requires, what we require that device to have, we can then deploy in NSO. Where we want to be, it is ultimately closed-loop orchestration. So using all the services that we do have internally and that we use for within Cisco IT. So for example here, NSO, ServiceNow, Science Logic. We want to use all three of those to have event-based driven and also user-based driven NSO changes. So for instance, a user requests a new service, it would go to NSO, it would provision the device with that service, or in contrast, you could have an event from Science Logic come in, say bandwidth is over, say your interface is over utilization and it's a service provider circuit. You could then go ahead and apply a quasi policy automatically. So some of the NSO use cases, we have got quite a few to go through. So we have a demo as well that we'll go through later, but some of them include sort of the ad hoc automation, which I've already mentioned, for one-off requirements. So although we still do one or two ad hoc scripts, they're made more generic so that you can then apply it to different use cases and different solutions. We've got the network lab service provisioning. From what you'll see in the next couple of slides, that is drastically reducing the time down to provision new lab services from around sort of 2 weeks down to 30 minutes. Security management, so that's a big thing globally. We wanted to roll out 802.1x and TrustSec globally, so we've managed to sort of automate that with NSO as well. Hardware software compliance, making sure that all our devices within the standards that we define. Automated infrastructure software lifecycle, that's a long one. OS upgrader, also known as OS upgrader. And then internet exchange peering management, which is what we're going to demo later for you, which you might be interested in. So some of the ad hoc operations, these come in different shapes and sizes, but what you can see up here is mainly what we use them for. So device password updates, so leveraging NSO, updating radius secrets, IPv6 configuration audit and remediation. So we have a dual stack running within Cisco. So we have v4, v6. And to make sure that everything is running as smoothly as possible, we go out and do these additional checks and also remediate any issues that we find. Quas auditing. So we use Quas throughout the infrastructure. We have pretty much everything you could ever imagine running across our circuits globally. So to keep this in check, we're continuously making sure that Quas is established and also within standard, so that this doesn't become an issue. Lab auditing. So we have ACLs globally that protect the internal Cisco network from any lab infrastructure that we have. So we make security products. Generally, we could be using malware in labs to test our security products. This ACL generally ensures that none of the traffic can get back into Cisco and do damage. And then object group cleanups. So network lab provisioning. If we take a quick look at what we have. So generally, we use ServiceNow to process lab requests. And you can see from the top, that's what we had in the past. So it's generally a long procedure. The user puts in a lab request in ServiceNow. You go through InfoSec approval. Depends how InfoSec are feeling on that day, whether it gets processed 1 day, 1 week, 1 month. Case for network turnup. So this gets put through to tier 1, and generally this will be actioned and reviewed by the engineer. And once that's done, it gets assigned. The engineer looks at all the requirements given by the client and all the address management needs, whether it needs to be a static infrastructure, whether it needs to be routed, with all those different things that you need to look at. Implement the network, and then the case is forwarded to layer 1 for patching. This is then connected. End to end, this probably takes about 2 weeks. But with from what you can see from the bottom is that with NSO, we can automate that whole life cycle. So opening the case, getting the config done, doing the implementation, and then also, obviously we can't do the patching yet, but yeah, the case then gets created with a layer 1 engineer to go on site and do the patching. So yeah, from what could be 2 weeks down to 30 minutes, I think that's quite an achievement. So what does that mean for us? So increased client satisfaction. So people are generally more happy that they get the service quicker, and that would probably be the same in your companies. Reduced man hours. So tier 1 no longer has to worry themselves over lab requests. They have more time to put developing new tools, also actioning other sort of cases that need extra sort of human intervention. Simple end user experience. So as you see, we use ServiceNow, and we also use something called eStore, which is an internally developed software and service portfolio management system. And enforce and validate security compliance. So we make sure that whatever we deploy is always within standard, and will always be protecting the internal infrastructure. So security management. As I've just mentioned, so we have ACL enforcement. So what we do globally is we have lab gateways that handle all connections to client labs. What we do there is an ACL is applied to the uplink, and this generally protects Cisco against any malicious traffic or requests that come through. And what we do is we check for 100% compliance and also audit monthly, so that any issues that we find will then be remediated and actioned by NSO. And then one of the extra things is TrustSec audit and deployment. So what we've done recently is we've gone to a full TrustSec environment. We've completely locked down ports. We've locked down wireless, and now this ends up in a 95 reduction audit and remediation done through NSO. So anything that is in place is audited, and we make that check. Anything that isn't will be remediated and fixed as and when the check is done. This has generally saved sort of about 8,000 man hours and generally 640 hours to develop the NSO model. So in terms of taking that into account, we've actually got a significant return on investment. So that's it for me for the moment. I'm going to hand over to Harry to talk about the hardware and software compliance. Harry.
Thanks, Tom. So as Tom demonstrated on one of the previous slides, we've got quite a lot of hardware that we have deployed all over the network. And Cisco's got an ongoing fleet program. So rather than just holding devices for, say, 10 years and then doing a bulk update, it's a rolling upgrade process. So sites and equipment are consistently updated on a smaller scale, so that it's a constant roll of hardware upgrades. So that allows us to run some of the services that we're looking to deploy in the future. We tend to find that the equipment tends to be able to support that service as well. And we do the same thing with software. So we tend not to just leave the software running as is and have it running, for 4 or 5 years there. We're constantly upgrading that software to make sure that we can use the services that we're looking to deploy in the future. And then at the same time, if there's P-certs, we'll remediate those very quickly. So for both of the hardware and software, we break them down into 3 classes. We place them as recommended, acceptable, and end of deployment. And so the end of deployment doesn't mean we need to replace it. It just means that we're no longer going to be adding that onto the network anymore. So what we do with NSO is we take all of the network equipment that we've got deployed, and then we've be able to run an audit very quickly and on a regular basis to see where we are with the states of these devices. So I'll just show you the workflow of how this works. So you can see on the bottom, we've got some of the sample devices that we have distributed on the network. And on the top right, we've got ServiceNow. And as Tom was saying, we use ServiceNow for client requests when they need to open up a service request. If there's an incident, that goes via ServiceNow as well. And if there's a change request, that goes via ServiceNow as well. And the individual devices that we have are added into ServiceNow as configuration items, so that then when there is a change request or an incident, you can assign those devices to that particular item that you're working in. So the population of these devices is done on a discovery basis. So we can actually use ServiceNow as our single source of truth for the distribution of equipment that we've got on the network. So that makes it a really useful place to populate NSO into the device inventory there, because as devices are added and removed from the network, they're added and removed from ServiceNow, and then we pull those into our production NSO on a regular basis. So as we've got that equipment populated into NSO, we can then run all of our services that we run against all of the devices on the production network. So one of the ones that we do is a hardware and software compliance check. So we use the platform field within NSO, and we work out and we run a service that takes the hardware, the software type, whether it's an iOS, iOS XR, iOS XE, and then the software version that's been run. And the service that runs, I think it's about once a week, compares all of those that are devices and software and marks out whether they're listed as recommended, acceptable, or end of deployment. And what we do is we place that report onto an external database, and then the clients from each of the IT groups can then look at that data in a visualized format and then see where their particular equipment stands in terms of compliance. And one of the things that's interesting, I think, is that it's the compliance group themselves that maintain those standards, and they use NSO to do the updates there. So we don't have to do anything. They maintain this, and this report runs on a regular basis, and they can, it's kind of self-run, which is pretty good. I'll show you some of the visualizations that we produced for the different groups. So you've got one on the left-hand side shown as the hardware report. And then on the right-hand side, we've got the software report. So again, the green devices are the ones that are listed running the recommended hardware or software. The ones in yellow are the ones that are acceptable, and the ones in red are the ones listed as end of deployment. And because we're running this report over a long period of time, you can actually start looking at trending as well. So you can see when, how you're doing in terms of upgrading your equipment or your software and where you're standing, or whether you're starting to drop down in your compliance as well. And you might be wondering what the grey devices are. So that could be one of two reasons. It's either that NSO can't reach the device, and so we need to investigate why we can't reach that, or it could be that the hardware or the software isn't explicitly listed as one of those standards, whether it's a recommended, acceptable, or end of deployment. So then, again, we need to find out why they're not using one of those 3 standards as well. So that's another kind of audit work that we can do. And then in terms of the OS report, I just actually selected the recommended section there, and you can see that over a period of time on the bottom, you can see that as people have been doing the upgrades on there, their compliance is increasing, and you can see where and when these upgrades actually happened. So that's more of a reporting view. One of the other groups within IT did develop this automated infrastructure software lifecycle, so an OS upgrade service. So I'm sure that many of you have worked with doing upgrades on devices by hand yourself. There's a lot of work that's involved with that, whether it's checking the device, making sure what that particular version of code is that you're meant to be running, making sure you've got the correct hardware standards, whether you've got the right disk space on the device, doing the verification of the image, making sure it's loaded in correctly, updating your bootloader and your bootstrap, all of that kind of stuff that takes time, and we tend to do it by hand on an individual basis. And if we're doing this on thousands of devices, it's not really efficient. So the solution is to try and abstract that complexity of what the operator does into Python code, and then use NSO to actually do the orchestration and the deployment of that. And the other part that we do is to the operator isn't actually going onto the devices anymore. They're going onto a dashboard and a view, and that's where they're actually using the tool to actually do the updates. They get the pre-checks and post-checks of when work's happening, so they'll check the status of interfaces, ERGRP neighbors, BGP, whatever the services are running on that, and it'll do a check post before and after and give you the report coming through. And then in terms of the other thing is that with ServiceNow, we've got the change request, and as we've mentioned before, we've got the configuration items that we can assign to that particular change request. The tool, if you provide the change request number, will then bring up those devices that are within that CR, and then you can actually do the work against them. So I can show you. This is the workflow, basically. So the client is no longer touching those devices individually. That's NSO that's going to be doing that. So they're just going to be using the UI, and that's going to be doing the REST calls to get the status of the reports and the instances for those individual devices. And again, the complexity and of how you're actually doing the checks is done via the Python side. And this is just to show you some of the screenshots. It's not very clear actually, but on the top left, we've got like the main dashboard that shows you the devices, whether they're up to date, which ones need staging, so which ones need the code to be pushed to them, and which ones for the iOS need to actually be reloaded. And so that gives you the status on the top left. It's a bit blurred on the top right is actually the staging view. So you can actually select all of the devices that you're interested in, and the ones where you need to put them into a staging state, you can actually select them and click the submit, and then it's actually going to orchestrate the upgrade of the iOS on. It actually do the staging of pushing the image onto the device itself, and it'll actually send you a notification when that's actually completed. And then if we follow this down, the bottom left is where you actually start doing the deployment. So if you've created a change request, you can put your change request number in there, and then that's going to bring up the list of devices that are affected by that change request on the left-hand side. And if they're up to date, it will show you that. That's fine. If the change request hasn't been approved, then it's going to actually flag up and say check your CR as well. So it won't actually allow you to do an upgrade if the CR hasn't been approved as well. But if the approval's done, then yeah, you can go ahead and start initiating those upgrades. And this is just a rough kind of count of how long it takes in terms of man hours. If you're having to do one individual device by hand and doing all of those checks yourself, compared to actually just deploying the request yourself. So that's a 30-minute versus a couple of minutes just to initiate that request within the UI. And Then that brings us on to the Internet Exchange Peering automation. So within Cisco, we have quite a few IPOPs. All of our internet access is distributed across different theaters. And just a quick overview of I think 70% is, if you guys are a service provider maybe, but for those that want a quick overview, with as we start consuming more and more internet traffic based on cloud-based services, the bandwidth that you use across your ISP links actually increases. And so one of the ways that you can try to offset that is to connect them into an internet exchange peering point, and then actually arrange direct peering with your clients. So for example, we've got some AWS and Salesforce and Apple peers listed here, so we can actually do direct peering with them. And so then you're, sorry, you're offsetting your traffic away from the ISP, and you can then use your direct access onto this exchange point. And that's useful because the costing associated with an exchange, they don't charge you on a bit rate. So you just pay a lease for the link itself. So that's a really useful way of of saving bandwidth on your main. Sorry, grab a drink. Yeah, so saving. Sorry about that. Saving bandwidth on your ISP links. So this is another view of that. On the left-hand side, we've got the ISP. I've got on the left-hand side, we've got the ISP traditional path, where when you're trying to reach those cloud services, you go over your ISP provider, you jump through the ASs, and then you reach the service. So you're going through the internet to reach those. On the right-hand side, we have the hybrid design, where your primary path is going via the colo, and you do a direct peering to them. And that's a direct peering, so it's a lot faster and it's more efficient. But if those links go down, you can still go via your ISP link as well. So it's not an either/or. So one of the things to bear in mind with your IXP peering is that it's for every single connection that you want to connect to, it's an individual BGP setup per client. So it's a lot of manual configuration. And we want to try and reduce these compliance checks. We want to reduce that potential for mistyping. We want to use NSO as the SSOT. So rather than looking at a spreadsheet or the router config itself as the list of the clients that we're peering with, we want to use NSO as the source of truth for the clients that we're connecting to. We want to reduce the time that we deploy these peers. And then lastly, we want to try and automate as much as possible the way that we pull in those devices and the entries that we have to add into the peering. We want to try and reduce the amount of variables that we manually have to enter. So I'm sure you've seen something like this before, which is like a BGP configuration, and this is traditionally what you would. That's traditionally a config that you would see for each individual peer on an IXP or ISP. And what we worked out was there's about 11 unique variables. So these are the things like your IPv4 address, your v6 address, your BGP AS, contact details, and your prefix warnings, things like that. There's 11 unique items that you need to provide per BGP peer. And that's around 18 lines of CLI per peer if you're using v4 and v6, which is what we traditionally do. And again, manual entry. If you're having to do this by hand every single time, then it's likelihood that you're going to miss something, or if a peer actually gets removed, you're going to leave some of the entries in there as well. And it's not uncommon to have peers where you could have 20 or 30 or maybe 40 peers on an exchange. And so if you're looking at 18 lines, if you're looking at 18 lines of code or CLI per client, then if you're having, say, 20 peers, then that's around 400 lines of CLI that you're trying to maintain by hand on the device. So what does it look like? This is just a quick view of the NSO model itself. So we built the Yang model to reflect how an operator would want to see this view of these peers. So the primary view is a list of the IPOPs, all of the different theaters and the internet exchanges, the internet points of presence that we have. And then if you drill down there, this is the Asia-Pac specific one. So we've got Hong Kong, Singapore, St. Leonard's in Sydney, and Tokyo. And if we select one of those particular IPOPs, such as Tokyo, we can then see a list of the exchanges that we've got deployed at that site. So in this instance, we've got Tokyo, and we've got a peering connection to Equinix on this gig link. And again, if we drill down from there in the next list, we had the list of the peers that we're actually peering with. So this is the this is the view of the those 11 variables that we were showing before. And so to actually deploy a BGP peer, you would need those 11 entries to be populated. And that's what we did initially. The NSO build was just to do this, and that helped us. It helps make sure that we're doing compliance, because all the engineer has to do is apply those details. It makes sure that the lines are compliant, and it's quicker than doing it by hand as well. And we still have NSO now as the single source of truth for these peers now. But it still takes time, because you're still having to look up these entries that are unique for this client, and so we were trying to see if there was another way that we could reduce that even further. So this is where we this is where we started looking at peering DB. So peering DB, if you don't know, is a web service where you can provide information. It provides information about exchanges. You can look at all the different clients that are actually using that exchange. You can look at their contact details, their addressing, things like that. So it's really useful. Or you can actually go the other way, and you could say, well, whereabouts does this particular company peer? And you can actually see all the exchanges where they actually peer. So one of the things that we found was if we provided the v4 address for a particular client that we knew we were going to peer to, we could provide that into the peering DB API, and we could pull out all of the other variables that we usually enter by hand into the system. The only one that we didn't do that had to be done with an automation within NSO itself is the AS path ACL, because that's something that's specific to the router config itself. So for every single peer that we have a unique AS path ACL. So the automated entry here actually goes and looks up the state of the router, and it looks to see what the last AS path ACL is, and then it just finds the next spare one that we can apply for that peer. And with that, we can probably do a demo of that, if that sounds okay.
You want another drink?
I'm kind of okay now, but yeah, that's
cool.
So I'll just connect onto one of our lab devices, hopefully. And I'll just leave this. I'll just do a term on, and I'll. And you can see we don't have BGP running here at all on this device. And this is actually peering DB. So I'll just show you an example of, if you haven't seen this before. So you can go to the main page, and you can look for a particular exchange that you're interested in finding out who actually is connected on that exchange. So for example, we'll go to links, which is in London Internet Exchange. Sorry, Equinix. And then you can see here on the right-hand side, we've got a list of the the individual clients that are connected to that exchange. And Tom, have you got any suggestions of a peer that we should look at?
NTT. NTT's here, so we could try NTT.
Okay, let's have a look. So we'll do an NTT. So we've got these details here. We've got the v4 address, and we've spoken, say, to NTT, and we've agreed that we're going to peer with each other. So now we're going to go and configure this deployment. So here's the. I'll do it from the view here, just so it's easier to see. So in this instance, we'll add a new IPOP. We're going to place this in London. And then we need to assign an exchange to this IPOP itself. So we're going to choose this lab box here that I've brought up, and we're going to call this links. And I know that this particular exchange connects on this gig interface here. So if I have a look at that, that's just going to add the service. It's not doing anything to the device. So from here, I can show you the first thing that we did initially, which is we can do this by hand. So we're going to do an NTT peer. And you can see all of these 11 variables are the ones that we had previously that we need to populate by hand. So we can go to peer in DB. We can say take this this address. We can take the AS number 12914. I'll make something up for this. And I'm going to choose an AS path ACL. In this instance, I would have had to have gone onto the router itself, find out what the next available AS path ACL is. But because we've got no BGP running on there, I'm just going to choose 100. And everything else I'm going to leave as default. So if I do this, it's going to populate the service, and it's going to configure BGP on this device. So that's good. It's, I can deploy this. And that's saving us time already. I'll bring this up. There you go. So it's come through, and you can see it's deployed. And if I do a show IP BGP, it's BGP summary. That's there. That's running. It's actually added all the entries from those fields that we did. That's okay. It means we're compliant, and we've got NSO using as a single source of truth for these peers. But then the next thing that we can do is demonstrate the one where we're just populating based on one v4 address. So here we've just added a new action item here. And do we have another suggestion?
Equinix. I know Equinix is here as well. So
yeah, we should be kind to Equinix because we chose links initially. So let's go. So here we've got Equinix that are actually connected to links. And so in this instance, you can see that the the way that peer in DB works is that they use the primary key of their setup being on the v4 address. And so from there, we can pull the v6 address details, and we can look at the contact details. So we can populate everything from there. So in this instance, I'll just provide the v4 address, I'll tell it what we want to do. So maybe I just want to do a lookup in this instance. So if I do that, and you can see we've got the the contact details being pulled up from the peer in DB API. So if we're happy with that, I can look up and apply instead, and then just run that. Wait a little while because my lab box is over in the US. Come on. There you go. It's got a transaction completed. Did the work. If I look at the BGP summary, you see now we've got two peers on there. If I do show BGP IPv6 summary, yeah, you get that peer as well. And you can actually do administration tasks with this as well. So if you wanted to, if you're doing some maintenance work, for example, that's one that really stands out as a problem. So if you've got 20 or 30 clients that you're peering with, if you're doing maintenance on that device, it's kind of polite to let those guys know that you're doing maintenance. And the other courtesy is actually to gracefully shut down your BGP peering with them as well, rather than just just switching off completely. So we can actually use NSO to actually go in and shut down those peers gracefully. If you look at that from a if you do that from a from the CLI point of view, if you look at the address family v6 and v4, and you have to actually remove the activate entry for every single entry, if you're doing that for 20 or 30 different clients, so that it's going to take a long time. So by one click, we can passive them all out. And when we've done the work, we can bring them all back up again. And I think the last entry was we just wanted to list. These are all the peers that we've got listed on there. We can again, we'll just go through the cleanup. So if we wanted to remove these, we can do this. And you can see that that's been done. If you do a show IP, BGP summary, BGP's gone completely now. So the whole config, all of the devices, all the peering configs, all been cleared out from the device. So there's nothing left over from when we were deploying it. That's it for me for the demo. I think I'll hand back to you, Tom.
Yeah,
I can
no
grab a drink.
So thanks, Harry. Returning to our journey, so just to wrap things up. The network tomorrow, so what do we expect it to look like? All of our services are defined in software. So from the diagram on the right, you can see a mix of NSO and DNA Center. We expect this to all come into one, automate, orchestrate. We shouldn't have to touch a device anymore. It should all go through NSO and DNA Center to be completely managed through and through. The orchestration layer, is going to be the source of truth. No longer sort of looking at devices and saying, yeah, actually that circuit ID, yeah, no, okay, that's it. The integration with business applications, that is becoming more of a reality. So we are becoming to base application and networking together rather than having the network first, then the application. And then, overall closed loop orchestration, so no touching of devices whatsoever. So I think that's everything that I had. Would like to invite any questions that the audience may have. Fantastic. Well, thank you very much.
Thank you.
So one of the things I was impressed by when I was seeing this presentation last fall, or a similar presentation anyway, is the variety of use cases. It's everything from small and simple scripts into quite advanced services, and I was struck by this creativity. How could you come up with all these different, very diverse use cases? Can you comment on that?
I think part of it is that from the IT side, we're broken out into different groups. So myself and Tom are working in the Cloud Foundation area. So our focus is primarily on the core routing and the IPOPs and the DMZ and the security there. So our ideas are kind of focused there. But because we have groups all interested and involved in working with NSO, they all find their individual use cases, and it all comes together in one package, which is pretty neat. And we can all share that as well.
Yeah, and another thing is, okay, so I've seen all these brilliant use cases, and you're using NSO in a very nice way. I mean, you're going this with a single source of truth and all of that, which is nice. But how could you, as a team, get to this point? How many are you?
I think our team in general is probably around approximately 20. So, and we've got a mixture of network engineers. We've got some people that have got more software, got more people that are more networking, got project managers. So I think within the team, we're definitely looking to look to become more agile. So from that aspect, we've got project managers learning agile skills, becoming scrum masters. We're looking to sort of get into the whole sort of backlog as well. So we have a backlog of activities we then prioritize. So obviously, if one thing becomes a priority, we then prioritize that, get it done, work as a team.
So 20, but how many of those 20 are actually writing NSO code or something like that? So scripts, actions, services?
So within the Cloud Foundation, as Tom's saying, there's 20 of us, I would say 20%, five of us maybe?
5 or 6, yeah.
that are working on it, and so we take those requests. That what we tend to do is we'll have a smart sheet. If people have got an issue or a request that they want to try and speed up and automate, they'll put that through on a smart sheet. So we've got a list of jobs that we're working on, and then as they come through, we start developing them as needed.
And can you, I don't know how, if you were there from the beginning when NSO was first deployed, and how did it start? Was it one guy first and that spread out, or how was it? Do you know?
Yeah, I mean, I think for myself, I didn't look too much at NSO until some of the guys over in US had been spending a lot more time developing it, and then they actually built a training package that we attended internally. So that was Jason and Brandon, that's right. Yeah. So we use that training package, and I think it's actually available on GitHub, so anyone can, if you search for it, you can actually follow it. It's a 5-day NSO training course, which is really useful. And so at that point, I hadn't looked at NSO. At that point, I'd kind of gone other options at the time. And so, and then once we'd done that, we started looking together and building use cases as a group. So, you know, with say 5 of us actually all literally working on say one Yang model and discussing how we're going to build this out. So it's, you know, we're not duplicating effort, and you know, how would it work from a workflow perspective. And so we worked on a few cases as a group before we started doing individual items as well.
Yeah, I think that training material has been instrumental in your development.
Yeah.
I mean, if you listen to Mark Swanborough's presentation yesterday up in the 5-6 room about building a pyramid of people that are leading this whole thing, I think that's exactly what you did as well. Mm-hmm. When Brandon posted this training material on the NSO Developer Hub back in November or something like that, it was the #1 downloaded or #1 viewed post for something like 6 months. And for a long time, it was more views on that one than the #2, 3, and 4 combined.
Yeah.
So I think it was really good material. And to make that investment in really educating yourself by making such material and then spreading it out to your peers, I mean, I think that is a key reason why you see so good results. At least from an outside perspective, that's what it looks like.
Okay, yeah, thanks.
Yeah, definitely. Thank you.
Hi. So I have a question regarding the business case. You had some numbers on this, we saved this many hours and so on. And I took it you had this smart sheet with different suggestions for automation items, right? Mm-hmm. Do you have any rule of thumb? Okay, our general payback should be 1 hour invested in developing it, should render us 10 hours in saving, or do you have any? Or is it just, this sounds like a good idea, let's do it?
I think it's a bit of both, actually. I think there is a bit of kind of finger in the air and sometimes in terms of savings. But one of the things that I find that's really interesting when I'm doing, if we're developing tools, I want to actually be able to provide actual data of how much use and saving it's made. So some of the things I tend to do when I'm building something is I'll actually generate logs of when people are actually using this tool, and I'll be able to look in there like in a generate a syslog or a trend. So then I can go into Splunk or something like that and say, well, how many times has this service been run in this quarter? And so then I can say, well, you know, it's been run this many times. If I can estimate roughly how much it would take to do it once, and then I can actually show that saving based on there. And it also helps me find out if it's actually being used or not. If it's not being used, I'm not going to carry on extending and building out from there as well.
Cool. Yeah, I like the way you're doing it pragmatically, as I would say it, right? Okay, here's something we can do. Let's spend a few days on investing.
Yeah, and what we tend to do is we break it down into really quick things that we can do. We'll look at something for a few weeks or a quarter. So that'll be the really quick things that we can get in and out. Yep. And then at the same time, we'll look at kind of the longer term 1-year projects that are going to take a bit more development time.
Cool, thank you.
So, excuse me?
Yeah.
I think I had is this on? So you both almost got there and Jan's question, kind of got me thinking. You started to go back in time to, hey, I have NSO, now what do I do with it? But one consistent theme throughout this conference has been the moments, the months before, when you're trying to motivate your team to do this. I know it's a Cisco product, but Cisco's a big company, and did you go through that cycle of selling, despair, convincing, just to get this automation, get any automation in there, and then in particular NSO, the way we've heard others in this group have done?
I think so. At one point, I think programming. So from network engineers in general, and other people that aren't necessarily developer and programming inclined, there's almost a part where, oh, do we want to program? I quite like the CLI, all the different things that you think of when, you go from network engineering straight to programming. It's like, no, I like my CLI, I like my boxes. It's gonna be fine. But no, I think sort of as it's gone on and as everybody's embraced the orchestration, automation sort of life cycle and how we can go forward with it. I mean, I'd say definitely in the last 2 years, it's been sort of quite a growth for us, saying, look, we can do this, and it's actually going to save us X amount of time to be able to provision these services. So I think it's a definite benefit, and I think we're realizing those benefits more and more as we go down that road.
And I think one of the other things that's interesting is when we're looking at the design, because like I say, the design, implementation, operation for a particular group is maintained now by ourselves. So when we're looking at a new service, we can actually think that when we're looking to build this or create a design, we can put the automation as a primary thought when we're developing them as well. So that's been useful, rather than kind of doing a drop down from the design guys coming through and showing what we're going to be doing, and then we have to say, well, how can we automate this? But we can actually do this because it's ourselves that are doing the design as well. Yep.
If I want to consider the BGP use case, how can you position the NSO? Is it an SDN controller or an orchestrator? Where's the orchestration function?
What we've tried to do is just minimize the amount of user intervention that's needed to deploy that particular config. So the first thing that we'd wanted to do was just the compliance side, was just to use that as our tool for that. And then what we've done from there is, once we've got this model defined, is try and reduce that amount of time as possible. So, when we're going to the point where we're trying to automate as much as possible by just literally providing that one address to do the automation side. And again, that can tie back through to the service amount packages and the e-stores. So, you put your order and your request, you can do the approval once it comes through, then you can actually send that off. So what we try to do is we document a lot of these service instances. We document the API. So even if somebody doesn't do networking, we can actually say, if this is on eStore and this service is approved, then this is the API call that you need to do to do this. So that's what we try to do as well, is at least provide that documentation so that somebody else can take it to that next level. So if it does get integrated into a eStore or ServiceNow request, then that's all they need to do. They don't need to look at the network side as well. Does that help? Yeah.
Any other comments? So you talked a little bit about the future. Do you have any ideas what the future for your team will be now? What's the next step for the team?
Yeah, and I think some of the things that we're trying to do as well is potentially consolidate with some of the other services that other teams are using. So one of the ones that stands out is maybe like a cloud port service. So if somebody's requesting an AWS service, that needs to be backhauled all the way back into Cisco, then they could we can automate the AWS side, and then if they're sat waiting for the network side to be deployed, that's kind of a bottleneck. So those are the kind of areas I think we're going to be looking to speed up automation. So it is literally an e-store request to do something like that and deploy it all the way through to the client's endpoint.
Leverage NSO just to automate the whole internal process, so that there's no waiting on our side in comparison to sort of getting something straight away in AWS.
Yeah, and that tends to be a traditional issue, I think, with the network side. You know, from an application, they install the application, then or service, and then there's that kind of wait time for, well, we're waiting for the network guys to go and figure this out and do the deployment. So if we can try and speed that part up, so we don't have to do that, that's a bonus as well.
So what was the hardest part about deploying NSO, or still is maybe?
I think one of the ones that we hit initially, and I was really interested in the LSA portion, is that we have quite a few devices, and it's hitting multiple theaters, and at the time we were trying to work out, is it better to distribute these and split them up geographically, or are we okay to put all of these devices into one NSO build and just do HA pairing or something like that? So that was one thing that I think took a little bit of time as well. Yeah, that's one that stands out.
Yeah, I mean, at the moment we have NSO appliances in each region. So, yeah, Americas, EMEA, Asia Pac. So we've gone for the split region. Not to say that could change, but at the moment it seems to be working.
Yeah.
Okay. So, yeah, just seeing how it goes. Still in the early stages, but.
Excellent. Thank you.
Okay. Thanks.
Thank you.
No more questions.